There's Emma Carr for you. Hello, Sarah, Rachel, Kiara that are watching this video. This is 10-3. This is all new stuff. Unless you have taken physics, then you might know some of this stuff already. So, complex numbers. Complex numbers, they a lot of times write in the form of a plus bi. Circle that or box it or do something. A plus bi. A plus bi. The very first thing that we're going to be doing in this section is graphing complex numbers, which are a plus bi, and they're really easy to graph. Like, they're really not that bad, okay? So, let's pick apart this a plus bi. A is going to be the part that is the real part, meaning it's like a real number. It's not an imaginary number. It's a real number. So, like 4 or 7, whatever, okay? The b part is the imaginary part, so it's separated into two pieces, okay? There's a real part and an imaginary part. So, when you graph this on an axis, okay, take a look at your x and y axis. X-axis is going to be the real axis, so it's no longer like the x-axis anymore. And the y-axis is the imaginary. You see how it's labeled with I-M-A-G-I-N. How do you spell imaginary? I-M-A-G. I don't know why that seems weird. Anyway, real axis, imaginary axis. So, like they graphed 2 plus 3i. 2 plus 3i. This means you go 2 as your x coordinate, and your y coordinate is 3. So we go 2 over, 1, 2, and 3 up. 1, 2, 3 to get to that spot. Very easy. Yeah? Yeah. Very, very easy. Okay? 4 minus 3i. You go 4 over. So 1, 2, 3, 4 over, and 3 down. That's where you get to 4 minus 3i. It's very easy. You're just graphing them like the real part is the x part. The y part is the imaginary part. Okay? Over, down, over, up, whatever. Right? That's what that looks like. Now, here's the deal. I'm going to talk about this one real quick. 2i, if they just give you 2i, 2 is the imaginary part. What's the real part on the front of it? 0. So you need to put it and maybe write it as 0 plus 2i. So you would go 0 left and right, but you would go 2 up. So it's going to touch, I don't know, wherever that is, right here at whatever.
Is it supposed to be a dotty line?
No. That's just saying how you get over to that point. There will be no dotted lines. It'll just be a dot in space. Okay?
Oh, it's a dot?
It's just a dot in space. Okay, so go down to example 1. We're going to do the first half of A and B, which is graphing it. First half of A and B. So if we're graphing 3 plus 2i, you're going to literally plot the point 3, 2. So you go over 3 and up 2. Over 1, 2, 3, up 2. And there is this point. This is 3 plus 2i.
It's just a dot hanging out.
It's just a dot hanging out. It's like just a coordinate point in space. Okay, good? All right, B, we're going to do the same thing. 4 minus 5i. It's like graphing the coordinate point 4, negative 5. Let's do it. 4, negative 5 is going to be in the 4th quadrant. 1, 2, 3, 4, negative 1, 2, 3, 4, 5. It's like too easy, right? 4 minus 5i. That's what we label him. There he is. Okay, good? Happy with that? That's the first part of it, okay? Now, what we want to do is we want to find the absolute value, okay? The definition for absolute value is finding the distance that each one of these points is away from 0. So check this out. We're kind of used to doing this. We're going to make this attached to the coordinate point 0, 0. So make a line. We're kind of used to doing that like as a terminal side of an angle, right? Making a line out in space, and we're attaching it always to the point 0, 0. And then when we find the absolute value, we're just wanting to find the distance right here. Like how far is that, right?
Mark it.
Okay. So if we're trying to find how far this is, I can use the Pythagorean theorem, yeah? Okay. So if I make this into a box, I make it into a right triangle. What's the x distance? 3. What's the y distance? 2. So I literally do 3 squared. This is a squared plus b squared equals c squared. C squared equals plus 2 squared. You see where I'm getting this information? Yeah. This is 9 plus 4. C squared equals 13. So c equals the square root of 13. We will leave it as the square root of 13 if it doesn't come out nicely, right? Okay? So you can probably do this without actually having to graph it, because take a look at this. This is your A, this is your B. We just square each one of them and add them together. Take a look at what the formula says. When we're finding the absolute value, which again is the distance from 0. So they'll represent it with those bars, the absolute value bars. You're just taking the first coordinate, squaring it, the second coordinate, squaring it, and you're taking the square root of that when you add them together, right? So if we just do this before we even look at graphing the thing, 4 and 5, okay? We take the square root, because that would be like c squared, taking the square root, of 4 squared plus... I always get rid of the negatives, right? Because you square a negative and it's positive. So I just do 4 squared and 5 squared, right?
Square root of 41.
So 16 plus 25 is 41. Yep, the square root of 41. And that does not come out nicely.
Nope.
So we're just going to leave it as the square root of 41. Happy with that?
Yep.
So happy. So
Okay.
if it does come out nicely, we just put the number.
Right. So like, let's say we have 2i.
60. Okay.
2i, like we had before, right? Okay. Is 2a or b? The value of 2, is that the a value or the b value?
B.
B, right? What's the a value?
0.
0 plus 2, right? So we would do the square root of 0 squared plus 2 squared, which is
4.
the square root of 4, which is
2.
2. And if you think about it, okay, on a graph, 2i, 0 comma 2i would just be up 2, right? What's the distance that this is away from 0?
2.
2. Like if you think about it on a graph, you don't even have to like do the thing, right? Like that makes sense, right? That's the distance that it is from 0, okay? Happy with that? That's what like the second half of your assignment is, okay? Like the bottom half of the first page. You're finding the absolute value stuff, okay? All right, this is going to be the hard part, so you need to really listen. And I'm going to try my best to explain it to you because Mr. Muth might do this differently, but we're gonna be okay, okay? All right, so let's say we have this point over here that's called a comma b, right? That's that place in space, and we connect him back to 0, kind of making an angle out of him, yeah? Okay? So we still kind of think about having the, the right triangle, the box that we have going on there, right?
Yeah.
Okay? And the radius is that absolute value, the distance that we just found. Like one of them was the square root of 13. Like if we had, what did we have? 3 plus 2i. Let's go with the square root of 40. I don't want to do that. I don't want to do that. Let's say we have, I'm going to give an example. Let's say we have that this point is negative,
3.
I don't know. Let's use the same number. Negative 3 plus 2i. Okay? That would be negative 3 plus 2i in that spot-ish, right? Okay? So his radius or his absolute value would be the square root of 13, correct? 3 squared is 9. 2 squared is 4. 9 plus 4 is 13, and we take the square root. So he would have a radius of the square root of 13. Does that make sense? Okay. Now, let's say we are trying to use sine and cosine to identify this spot right here. This is what's called polar form. Okay? We're trying to make it into polar form. So all we do is look at this angle, which is called the reference angle. We connect it back and we make like a bow tie out of it, right? Like what we just got done doing. We make a bow tie out of it. Okay? So we're looking at this angle right here. Okay? All right. So let's look at this side of my triangle. And what length is that? Like that bottom side of my triangle. What do we got? Negative 3. And over here, this has a height of 2, yeah? Okay? So we're going to use sine and cosine of all this stuff to figure out where that dot is located, okay? And they say write it in polar form. All right, so
13.
what?
13.
So polar form is just going to look like similar to this right here. R and then cosine of theta plus I sine of theta. Let me show you how this works, right? R, what is R in our case? This radius, the square root of 13, that's like that absolute value. It's the distance that he is away from 0. It's that radius value, right? Okay? And then we do cosine of theta. Now, why do they do cosine of theta first?
Because.
If you remember from your unit circle, what does cosine of theta represent?
That's X.
The x coordinate, right? Cosine of theta is the x coordinate, okay? Plus I times sine of theta. And sine of theta represents the y coordinate, yeah? Yeah? Good? Okay, so the square root of 13, parentheses, cosine of theta plus I sine of theta. Now, this I just comes from like the a plus bi, like the a plus bi here. It's just like they wrote the I in front of the sine of theta instead of at the end of sine of theta. But this is kind of like what your polar form will look like, except we have to solve for theta. but this is like the skeleton of what polar form looks like, okay? So this is switching from negative 3 plus 2i to polar form, which is the square root of 13 times cosine theta plus I sine theta. Cosine meaning x, sine meaning y. That's how that works, right? And the square root of 13 just tells how far it is away from 0. Make sense? Ish?
Yeah.
Clear as mud?
Yes.
Okay, sure. Okay, every complex number, I'm going to read this box. A plus bi is a complex number. Every complex number can be written as polar form by doing that, right? Kind of what we just did, okay? Every complex number can be written like that, okay? Now, we're going to finish this example off really quick, and let's actually figure out what theta is. Can we do that? Yeah, let's figure out what that angle is. We can do that using SOHCAHTOA stuff, right? We can do that really easily using SOHCAHTOA. Let's use tangent, right? We have 2 and we have negative 3, okay? So we have opposite and adjacent, okay? So if the opposite side is 2 and the adjacent side is negative 3, we would say that tangent of theta is equal to opposite adjacent would be 2 over negative 3. And how do I solve for theta? Arctangent or inverse tangent. So inverse tangent of negative 2/3. And that theta is how much?
33.69.
Negative 33.69?
Yeah.
Okay, now, question. I'm going to go 33.7. Let's just go one decimal place.
Angles
Okay?
can't be negative.
Now, angles can't be negative. That's weird. Why did they give it to you as a negative angle?
The quadrant.
You're in the second quadrant, okay?
Tangent
We
is negative.
really want our angle theta to actually be the distance in standard form that direction. So if this is 33.7, how do I find this amount?
180.
180 minus the 33.7, right? So that's why I gave it to you as a negative. So what would that be? 146.3. Check me.
Do we or not?
Okay? So that's our conclusion of switching from polar form. Negative 3 plus 2i is a complex number. This is a complex number. And to switch to polar form, the full switch to polar form is the r. I'm just going to write this in here. R cosine of theta plus I sine of theta. This is the form that it needs to be in. So r we said was the square root of 13. Cosine of theta is the 146.3 plus I sine of 146.3. This is the full-blown putting it in polar form. Was that confusing?
Yeah.
A little bit. Let's do another one like that, okay? Should we do a homework assignment like that?
Yes. Maybe.
Maybe. I mean, yeah. We'll do a homework problem rather than doing example 2, okay?
So will we always
We'll do
use
example 2 tomorrow.
Will we always use tangent?
Yes, usually, yes. Yes, to find that angle theta. Okay, so let's go to one of your homework problems. Express each number in polar form. So you have 1, 2, 3, 4, 5, 6 of these to do, okay? Keeping in mind, like number 3 and number 6, let's write those as a complex number, as a proper complex number. So number 3, the 2 is the A or the B, which one? B, okay, so what will the A be? 0. So rewrite this as 0 minus 2i if you need to, okay? What about number 6? What will that look like?
3 minus 0i.
3, I'm going to do 3 plus 0i. It doesn't matter if it's minus or plus because it's 0, okay? So if you need to rewrite those as a proper complex number, you can do that, okay? So number 1, we're going to do number 1 together. 3 plus 3i, right? 3 plus, can I not do number 1? Number 1's in the first quadrant. Let's do number 4. Let's do one that's not in the first quadrant because this is going to be a little bit, well, number 4's in the second quadrant though. Let's do 5. Sorry, I'm trying to pick one that's a little bit harder. Let's do number 5 together, okay? So 5, what quadrant is 5 in? Fourth quadrant, right? 2 over and 2 down, right? So there he is. This guy, and I make him into a triangle. Okay? Let's label the sides of our triangle. So this is 2 and this is also 2, but make sure you label it with the negative because when you do tangent, it will matter. Okay? All right, so first thing we need to do, we're switching it from a complex number to polar form, which is r times cosine of theta plus I sine of theta. Okay? All right, so
square root
the
of 8.
only thing we need to figure out is what r is and what theta is, and then plop them into our formula and write it in polar form, okay?
Square root of 8.
So r is this distance right here, okay? It's just doing the Pythagorean theorem, right? Okay, so we do 2 squared plus another 2 squared. It doesn't have to be a negative 2. And we take the square root of that. Square root of 8. We're going to leave it as a square root of 8 because it doesn't come out nicely. So that's what my r is. Questions about that?
No.
Okay, now we just have to figure out what the angle is, right? This angle right here, okay?
Negative 45.
All right, so we're going to use tangent where negative 2 is the opposite and 2 is the adjacent. Confusion about that?
No.
Okay, so we're going to do tangent of this angle theta is equal to opposite over adjacent, so negative 2 over 2. Okay? Can you reduce that to negative 1 over 1?
No.
Yeah, you can. It doesn't matter. Okay? So we do arc tangent, so theta equals inverse tangent of negative 2 over 2 or negative 1 over 1, doesn't matter. Okay? And it's negative 45 degrees. Okay? Now we're almost done. That's not what theta is. That means that this angle right here is 45 degrees. Okay? But I want to go in standard form all the way around. So we're reflecting an angle in the fourth quadrant, right? If you say 45 degrees, I'm going to say that you're in the first quadrant. How do I say that that's in the fourth quadrant?
135.
Nah,
315.
315. In the third quadrant, and the fourth quadrant would be 315 degrees. If I subtract 45 from 360, do you see how that works?
Yeah.
360 would be all the way around, yeah? And 45 degrees less than that would be a 315 degree angle, right? Do you see how that works?
Yeah.
Okay, it's 45 degrees as that angle in my bow tie, but reflecting that it's in the fourth quadrant, we have to use 315. So 315 degrees is my angle theta. That means that polar form, just written the whole thing out, is the square root of 8 times cosine of 315, and you can put parentheses around it or you don't need to, plus I times sine of 315. And that is polar form. Happy with that? You just need to find r and you just need to find theta, but make sure that when you find your theta, after you do your tangent, you reflect what quadrant it's in, right?
How do you
Okay.
do 3
And that's
6 then?
all. 3 and 6 are going to be a lot easier than you think they are.
Can you compare?
You just do it exactly the same. Should we do one of them?
Yeah.
Let's do one of them.
No.
Let's.
No.
They're not bad. They're not bad. In fact, you don't even need to do your tangent thing. Which one? 3 or 6? Which one would you like?
3.
3. Let's graph 3. 0, negative 2i. Where does that live? 0 left and right, negative 2i down. Right here. Is this dot. Okay? You don't even need to do any equations. What is r going to be? What's the distance that it is away from 0?
2.
It's 2, right? Okay? Now, what is your angle theta going to be?
270.
It's starting from here and going down to this terminal side. How many degrees is that? 270. This is number 3. So when they give you like an A or a B that is 0, just look at where it's located and how many degrees that is. Do you see why we get 270 degrees from there?
Yeah.
So,
6.
Polar form would just be 2, parentheses,
Cosine.
cosine of
270.
270 plus
I sine.
I sine of 270. Make sense?
6 would just be cosine of 0, sine of 0. Right?
Because 3 is not.
Because 3 would just be over. So yeah.
Yeah.
Yeah. Now,
What?
some people also instead, Marcus, will do cosine of 360, sine of 360, because we'll do that too. But I would do 0. 0 just makes more sense. Okay? So when you, like 3 and 6 are going to be a lot easier. Just look at the graph of where the angle is located and how many units it is. Okay?
Can I summarize
So
you?
you should be able to do the entire first page. The bottom is just graphing them, right? So do 1 through 12. Tomorrow we'll do the backside stuff. Okay? What? No, we didn't do 6, but just think about it. Just graph it and find where it's located. Okay? All right, goodbye, people in the video.